Hello everyone. In this example, we're asked to find the equation and the foci of the following ellipse, and that ellipse is just the ellipse that is given in this picture here. And so we can make some assumptions, right? These are going to be the endpoints or the vertices of our major axis, and these are going to be the endpoints or vertices of our minor axis. And so we can observe that our major axis is going to be our horizontal axis. And so that means our equation for our ellipse is going to be of the standard form x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Remember, we always use a as the larger of the two values corresponding to our major axis. And so our horizontal major axis tells us that that larger value is going to have to be under the x squared term instead of that y squared term. All right, so now we need to start picking apart the missing pieces of information from our standard form. What is h, what is k, what is a, and what is b? Once we find those, we'll then be able to use that to find the foci of our ellipse. And so I think we could get started in pretty much any of these places. Let's go ahead and find the center of the ellipse first. So it might be really easy to kind of visually inspect what the center of our ellipse is from these four given points, or we can always just find the average between a pair of these points on the same axes, and that'll help us find the center of our ellipse, right? What is the midpoint, or what is halfway between the points -3, -2, and 9, -2? That's going to be the same as the point that is halfway between 3, -1, and 3, -3. Either way you go about finding it, you should find that halfway or midpoint or center of our ellipse is the point 3, -2. All right, so far we've identified the center of our ellipse, and that gives us our h and k values of 3 and -2 respectively. Next, we need to find a and b. And remember, a and b are related to the length of our major and minor axes. Right, how far we have to go from the center to one of the vertices on our major axis is a. And so we could go in either direction there. So this horizontal distance between -3, -2 and 3, -2, our center point, that is our a value. And it looks like that horizontal distance is 6. Right, we got to add 6 to -3 to get to +3. And we can double check that on the other side as well, which is a nice thing to do. Always check if you can. What do we have to add to +3 to get to +9? Well, that's also 6. So a is going to be equal to 6 in the equation for our ellipse. Right, we go through the exact same process to find b, but b is related to the minor axis, which is our vertical axis in this example. And so how far above our center point do we have to travel to end up at the top of our minor axis, or the point 3, -1? Well, we go from -2 to -1 in the y direction. So that tells us b is going to have to be equal to +1. And we can check that down here from the center point. If we travel 1 unit down, we get to 3, -3, the other endpoint of our minor axis. So we found a, b, h, and k. We now have all we need to construct the equation of our ellipse. And so just plugging in our values for h, k, a, and b, we see that the equation that describes the given ellipse is the quantity x minus 3 squared divided by 36 plus the quantity y plus 2 squared divided by 1 is equal to 1. We don't need to write that numerator of 1 there, but I'm just writing it to make it look as much like our standard form as possible. So we're almost done with this example, but we have one last task to complete, and that is to find the foci of the ellipse. So remember, to help us find the foci of our ellipse, we have to find that special c number, and the relationship between a, b, and c was that b squared is equal to a squared minus c squared. So if we plug in our a and b values, b squared is 1, a squared is 36. Moving things around, we see c squared is equal to 35, or c is equal to the square root of 35. And so now that we have our c value, we have to use the fact that our foci are always c units away from the center in the direction of that major axis. Our major axis was horizontal. Our center point was at 3, -2. So we have to move horizontally c units away from the center in either direction to end up at our foci. And so if we move the square root of 35, or just under 6 units to the right of our center point, we end up at our first focal point that I'm labeling F1. the exact coordinates of that point are 3 plus the square root of 35 for the x coordinate and just -2 for the y coordinate. If we travel the square root of 35 units in the horizontal direction or to the left of our center point, then we get our second focal point, and that'll have coordinates of 3 minus the square root of 35, comma, -2. And so just to summarize and put our answers in a nice little box, maybe put a little bow on it, our equation for our ellipse is the quantity x minus 3 squared over 36 plus the quantity y plus 2 squared over 1 equals 1. And our foci are the 2 points where x is 3 plus or minus the square root of 35 and y is -2. And we should be able to check our equation by plugging it into a graphing calculator, although you have to be careful. If you're using like a physical graphing calculator, you can't enter in these implicit equations. We have to solve for y in terms of x, which can be a bit tricky. But if you use a website like Desmos, it'll allow you to enter an equation in its implicit form, which is what we have here, and it'll graph it in its entirety. So checking your graphs using something like Desmos is probably easier than using like a physical graphing calculator.